elementary probability, and counting methods. Probability is simply the likelihood that an event will happen. It's calculated by dividing the favorable outcomes by the possible outcomes. For example, if you flip a coin, what is the likelihood that it will be tails? Well, the favorable outcome in this case would be 1, and the possible outcomes would be, of course, 2. The coin will either be heads or tails. There is no other option. So we're left with 1/2, or 50%. Continuing off of this, probabilities can also have multiple events happening. In order to calculate consecutive probabilities, multiply the individual probabilities. For example, what's the probability of drawing a blue marble and then a red marble from a bowl containing 4 red marbles, 5 blue marbles, and 5 green marbles? Assume that the marbles are not replaced after being selected. There would be a 5 out of 14 likelihood of selecting blue marbles first, the favorable outcome over the possible outcomes, and a 4 to 13 likelihood of selecting a red marble second because the blue marble did not go back. Multiply these values to get 20 over 182, which simplifies to 10 over 91. And that's the probability. When dealing with lots of numbers for probability questions, it can be helpful to know whether it's a combination or a permutation. A combination is a group of numbers where the order does not matter. 5, 10, 15, 3, 13, pi, whatever. It doesn't matter. A permutation is a grouping of numbers where the order does matter. Like a phone number. The order you put that in matters.
Hello.
With both of these sequences, it's important to know whether repetition is an option. If there is a permutation of numbers where you can repeat from the same list of numbers, then you can set n, the number of things to choose from, and raise it to the power of r, how many things being chosen. So if you have a phone number that you had to guess the last 2 digits of because it was smudged, you would have 10 numbers to choose from, 0 to 9, and you would raise that to the power of 2 to get 100 permutations, or a 1 out of 100 probability of guessing it correctly. For permutations without repetition, we will need to lower the amount that we are choosing from each time. So if you took 4 marbles out of a bag, all different, what would the different permutations be? We would multiply each of our possibilities together, and that would be our answer. 4 times 3 times 2 times 1. So there are 24 permutations of taking out the marbles. This can also be written as a factorial. So 4 factorial equals 24. But if we are only taking 2 marbles out, then we would need a different formula. N factorial divided by n minus r factorial, because we don't need to multiply the rest of the numbers. For combinations without repetition, it will be less than the formula for permutations without repetitions. The formula for that is n factorial divided by r factorial times n minus r factorial, because we're no longer interested in the order that the numbers come in. And for combinations with repetition, we have the formula n plus r minus 1 factorial divided by r factorial times n minus 1 factorial. How did we get that? Well, it's a bit harder to deduce, but it's like inputting commands into a machine, where it needs a certain number of 2 types of commands, select and move. Select by selecting a number, and move meaning moving to another possible choice. This formula allows us to find all the possible combinations. Most questions you can figure out without using these formulas, but it can be helpful for more complex problems. One last bit on number representation before we move on is utilizing Venn diagrams. A Venn diagram is helpful for visualizing overlapping sets of numbers. The total number will equal the number in one group plus the number in the other group minus the number common to both groups. For example, if in a certain school 20 students are taking math and 10 are taking history and 7 are taking both, how many students are taking either math or history? In order to know the total number of students, you can use a Venn diagram. 10 in history, 20 in math, but 7 are in both. So you add together 10 plus 20, then minus 7 to know the total number of students, 23. Let's try an example problem. Sarah cannot completely remember her 4-digit ATM PIN number. She does remember the first 2 digits, but she knows that each of the last 2 digits is greater than 5. The ATM will allow her 3 tries before it blocks further access. If she randomly guesses the last 2 digits, what is the probability that she will get access to her account? Randomly guessing either of the last 2 digits does not affect the choice of the other, which means that the events are independent, and we are dealing with consecutive probabilities. Since each of the last 2 digits is greater than 5, Sarah has 4 digits to choose from, 6, 7, 8, and 9. Her chance of guessing correctly on the first choice is 1 out of 4. On the second choice is also 1 out of 4. Her chance of guessing correctly on both choices is 1 out of 4 times 1 out of 4, which equals 1/16. Since she gets 3 tries, the total probability is 1/16 plus 1/16 plus 1/16, which equals 3/16. And that's our answer.